CEA class, this is Mr. Voigt. We are going to go over how to do a beam analysis, using the formula method. So before we used the algebra, where we wrote our algebraic equations, now we are going to use our formulas that are right here on your formula sheet. So here's what we're going to do. First thing I need you to do, we've done this before, is take this beam, put it in a free body diagram. So we need to put our uniform load on here. And remember, uniform load goes all the way across the beam, puts the same amount of weight on the beam per foot all along it. Oops, I did that wrong. That's pounds per foot. You got to put your concentrated loads on here. So P equals 650 pounds. P equals 800 pounds. Okay, then you got to put your reaction forces, RYA and RYB. And we know for the purposes of doing these particular beams, we always have Rx equals 0. There is no force pushing horizontally. Although in some cases in real life you would have to account for that. We are just accounting for the vertical forces. Okay, so that's what you do. Now you also have to put your distances. So if you look up there, this is 5 feet between there and there. If you go 5 to 7, that's 7 feet. And you go here to here, 12 to 18, that's 6 feet. So that is your free body diagram. Okay, so turn the page. So what we are doing, just so you know, we used algebra before to take all of these forces and come up with a total, so that we know that if there's X amount of weight coming down on this beam, no matter whether it's concentrated or uniform load, that we have to resist that with our RYA and our RYB. So really this whole process is figuring out how much weight is coming down on the beam, and of however much is coming down on the beam, how much of that is being carried at this end and how much of that is being carried at this end. They may not be equal, okay, depending on where these loads are located and how they're distributed. And we should understand that by now. Okay, so just like before, we need to find our end reactions. So this is what we've been doing up till now. The bending moment is what we've been doing, finding the area on the graph. Okay, so our end reactions, it says show the formula equation and solution for your end reaction. So the first thing we do is do our total. So we go RYA plus RYB minus, remember, and we have a uniform load of 160 pounds per foot, and our beam is 18 feet. So we subtract 160 pounds over 18 feet, and then we subtract our 650 and our 800 on this. So we go minus our 650 minus our 800 equals 0, right? Okay, so we can go 160 times 18, 2880. So we go RYA plus RYB minus 2880 minus 650 minus 800 equals 0. So our RYA plus our RYB equals, and we just use algebra, right? 2880 plus 650 plus 800, 4330. That's in pounds. 4,330 pounds. Okay? So we've done this before. Now, we used to write then an algebraic equation to figure out, so this is our total weight. That's our total weight coming down on our beam, right? So how much of that 4,330 pounds is going to RYA, and how much of that 4,330 pounds is going to RYB? That's what we're going to figure out next. That's our end reaction, the reactionary forces that are holding up this load. Okay? So before we would we would write out our algebraic equation. I don't want to review that. I just want you to remember that we did it. So here, we're going to use is formulas. So they have formulas for a beam with a load in the middle. They have a formula for a uniform load, and they have a formula for what they call a symmetrically loaded beam. So P and P are the same distance from the end, and they're the same weight. So if you don't have those conditions, you can't use this formula. And then they have one with just a uniform, or with a concentrated load, you know, some distance off one end. So we're going to have to do that because we have two concentrated loads that are don't have the same distance from each end, and they're not the same weight. So we can't use this formula even though we have two concentrated loads. We have to do this one twice. And we have a uniform load. So we're going to have to use this formula, and then we're going to have to use this formula and this formula for one load, and then we're going to have to use both of them for the second load, and then we're going to have to add everything together. I will show you. So we are going to break this into three parts. So we're going to say uniform. This is our uniform load. We're going to go ahead and do that. The formula there is WL over 2. Okay, W being our uniform load, L being the length, divided by 2. So we say for that, RYA equals RYB, and the reason they are equals because a uniform load will be distributed equally between them, equals WL over 2, which equals 160 times 18 divided by 2, which equals 2,880. We already figured that out over here, right? Divided by 2, which equals 1,440 pounds. So RYA is going to hold 440 pounds of the 2,880 pounds of the uniform load, and RYB is going to hold 1,440 pounds of the 2,880 pounds on the uniform load. That makes sense. It's a uniform load. It's distributed evenly, so they're going to hold the same amount of the total. Okay, so we're going to say concentrated. Let's just call this, instead of calling it concentrated, we're going to say P1. Okay, P1, if we look here, is this load right here. It's 5 feet from this edge, and it's 650 pounds. So when they put this on our formula sheet, let me show you this. They say if you have a uniform load, this little distance right here is A, and this distance here is B. Okay? And then you use these formulas. So I'm going to go ahead and write these formulas on here. So we say RA equals PB over L. And RB equals PA over L. Okay? So if we do this, P is our load, B is the distance. So we're going to say 650 times, and B, remember, is this distance right here, this total distance. So 7 plus 6 is 13. So times 13 divided by 18 equals, this is going to be 650 times the other distance, which is 5, divided by 18. And so that's going to be that. So the load on the A side, PYA and PYB, the load on PYA from this load is going to be this answer right here. So I'm going to go ahead and do that. 650 times 13 equals, divided by 18. So we get 469.44 pounds. So of our 650 pounds, 469.44 of them are going to be carried by RYA's reactionary force. Over here, we'll do it again. 650 times 5 equals, divided by 18. And 180 of them, 0.56 pounds, are carried by RYB. Now, theoretically, so this load is 650 pounds, so this plus this should equal the 650. We're very, very close. We had to round, so it's very possible that we are I don't know, a tenth of a pound off or something. Nope, comes out exact when I round correctly. Okay, so that load's 650 pounds. We know that. 469 of it's going to be carried by RYA. And why is 469 pounds of this load going to be carried here? Because it's closer to that. It's going to be the opposite here. Most of this is going to be carried by RYB. Okay, so then we're going to do P2 right here. And we're going to say 800 pounds times B, right? So that's this one right here, times 6 divided by 18. That's going to be RYA. And our RYB is going to be 800 pounds times 12 divided by 18. Okay, so we're going to go ahead and do that. 800 times 6 equals 800 divided by 18. So that can't be right. 800 times 6 equals divided by 18. times 800 times 12 divided by 18. 533.33 pounds. Let's do this again. 800 times 6 equals divided by 18. So I knew I was wrong. I don't know what I was typing in wrong there. 266.67 pounds. So of the 800 pounds, RYB is going to hold 533.33 of them, and RYA is going to hold 266.67 of them. Again, these should add up to 800, right? So 266.67 plus 533.33 equals 800. So we figured out of our load how much is distributed where. So now we just got to add these up. We know RYA and RYB hold 1400, so we're going to go RYA equals 1440, we get that from here, plus 469.44 pounds, plus 266.67 pounds. So we get a total of, the total load on so I just typed that in here. Sorry, I should have shown you while I did that. We get a total load of 2,176.11 pounds being held by RYA. RYB is going to be 1440 plus our 180.56 pounds plus our 533.33. So I'm going to add that up. So 1440 plus 180.56 plus 533.33. So 2,153.89 pounds. So of our total 4,330 pounds, RYA is holding this much and RYB is holding this much. Now, theoretically, these should add up to that, right? So let's just, the reason I'm adding them is to double check my work. If I did it wrong, then they won't add up. And look, those two add up to exactly that. So that's how you do this using formulas instead of the algebraic equation. All right, guys, I'm going to go on in the next video and talk about bending moment.